Alright, good morning class. So at this point in our lives we were busy with Euclidean Geometry Chapter 8 from the Mind Action series. Not so? Alright. Your homework was exercise 1 on page 251. It was quite a few sums. It's number 5 and 6 to start off with. Not so? Alright, so number 5. We spoke about the proof. We spoke about many things. Okay. Remember, the proof is coming in. You need to go learn that thing. No? Let's add a page here. This is exercise 1, page 251. As I said, this will be different pages for different textbooks, especially when it comes to the workbook. The workbook's numbering is different to the textbook itself. Okay. That said, let's do this. So the question says in triangle DEF. In triangle DEF. So as I said before, they're going to name the big triangle. Okay. So we are told that GH is parallel to EF, which means to say that DH over HF is equal to DG over GE, and all these variations that goes with it. Okay. Then we are told that DG is to GE as 5 is to 3. The same thing is DG over GE is equal to 5 over 3. So what do we say? We're going to introduce a K here. So that's going to be 5K and GE is 3K. Not so. Then DE is 30 DE is 32 millimeters then. DF is 24 millimeters. Find the length of DG and a whole lot more length. So if DE is 32 centimeters, in terms of K, what is DE? DE is what? 8K. Not so. So that's going to give you 8K. So what does K actually represent here? We can say that 32 equals 8K. So K is equal to what? 4. 4 what? Units. Not millimeters, units. Okay? So in other words, there's going to be 5 times 4. And what's 5 times 4? 20. And what's 3 times 4? 12. So you see, what did I ask you to work out first? DG. I just worked out DG. So you just say DG, which is equal to what's that? 5K. It's going to be 4 times 5, which is 20. Not so. Then GE, which we did equal to 3K. So that would simply be 3 times 4, which is 12 millimeters. Okay, not so. Then they want to know DH. So DH, let's just close it. They want to know DH. How are we going to calculate DH? We know that DH over what? What are we going to say? DH over? Can I go with HF? No. Why? There's a DH and HF is unknown. That's why I'm not going to go with HF. EF? DF. Yeah, DF. Why do I'm going with DF? Because I know that is 24. You guys understand? So we're going to say DF equals So dH over dF is equal to dG over dE. Why? Is a proportionality theorem with GH, which is parallel to here. So DH is what we would calculate. DF is 24 equals DG, which is, you can say 20 or 5K, doesn't matter, over DE, 32. If I had gone with 5K, then I had to use 3K. Can you see that? Sorry, 8K. But since I use the millimeters, I need to use the millimeters now. Does it make sense? Okay? So what I'm going to do is I'm going to cross multiply them. So DH is equal to 20. So it's 20 multiplied by 24 divided by 32. He's going to give you 15 millimeters there. Any issues there, people? No? I'm going to put 15 in. Then, let's change the color. They want us to work out HF, which is this length here. So how do you think we're going to work out HF? 24 minus 15, which is 9 millimeters. And you see that, oh, this is geometry we're working in, and that's the only reason you need it. When you're talking about lengths and stuff like that, you don't need that reason. Does it make sense, people? Okay. Then we gave you number 6, or I gave you number 6. So exercise 1, page 251. Number 6. You guys are understanding this, no? You all understand. There's a lot of marks in your exam, no? Don't mess this up. Right, number 6. In triangle PQR, which is a big triangle, we are told that ST is parallel. So ST is parallel to QR. So PS over SQ is equal to PT over TR. And all its variations that goes with it. Okay. Then we are told that PQ is 35. So PQ is 35 then. So I'm writing this in now. 35 millimeters. PR is 25 millimeters. QS is 14 millimeters. Determine the length of PT. Okay, but if you look at what we have, can you calculate PT at this point? What can we actually calculate? PR. That is what can be calculated. Why? Because we can see here that QS over PQ is equal to TR over PR. But they want this one here. So what we're going to do is once we got PTR, you can just subtract that from 25, you'll get what they're looking for. You guys understand? So we don't force the equation to work out with the ratio to work out PT. Alright, that's one way. Or what we could have done was we could have worked out PS first, which is 35 minus 14, which is 29, 19. And then I could have worked out PT in that ratio. You all agree with that? And I'm going to go with the first one I had in mind. But that is also an option. It should give you the same answer there. You all okay with that? So let's go with it. QS over PQ is equal to TR over PR. Why? Because it's the proportionality theorem with ST being parallel to QR. Okay, so QS is 14 over 35 is equal to TR, which is TR, which I'm calculating at this point, over PR, which is 25. So what do? I cross multiply. So that will simply be 25 times 14 over 35 is equal to TR. So TR works out to be what? So it's 25 times 14 over 35. I'm going to give you 10. Is absolutely correct? 10 millimeters then. But I haven't answered the question. So therefore, PT, PT. Did you say them, no? Yes, you see, I know some of you. Right, PT is equal to 25 minus 10, which is 15 millimeters. Okay, any confusion here? No? Then I ask you to do, what does the next one ask you to do? 7 and 8. No, only 7. Okay. 7. Okay, I just gave you numbers that look similar to what I've seen over the past couple of years. I haven't seen a sum similar to number 8. That's why I left the 8 out. I think 1 or 2 others I also left out. No? It's just to do with what is familiar, man. Because I don't want to give you a vast variety of these things if the exam concentrates only on this type of shapes. You understand? So that's the idea here. Before you thinking why not 8, and then you get expecting 8 in your exam. No. Okay. And just give you things that is applicable to examination. Okay. People, look at number 7. In number 7, we are told that in triangle ABC, so here we got 2 triangles, 2 big triangles. We are told that AC is parallel to DE. So if AC is parallel to DE, then AD over BD is equal to CE over EB. You all agree with that? And its variations. Okay, then in triangle BCD and BCG, CG, no, it's parallel. So if these lines are parallel, what do we know? That CE over EB is equal to GF over FB. The question says prove that is equal to. The same thing here, they could have said prove that AD over DB is equal to GF over FB. Again, I'm not one to work much with ratios. I like fractions more. But if you can work with it in fractions, it's fine. Okay. But as I said, I just feel more comfortable going the other way around. Okay. So where do we start? You see here we've got AB, AD and BD. So we've got AD. So we say in triangle ABC. You don't have to say that. Okay, but just not to get confused. In triangle ABC. We know that AD over DB is equal to CE over EB. Okay, so AD over DB is equal to CE over CB. As I said in the last lesson, you're going to hear me repeat things over again and over. Why? Because that's a bit confusing. Okay, and I don't want to write the wrong thing down. So take your time with it. Make sure you're writing the right stuff down. Okay? And what's the reason here? the proportionality theorem with AC being parallel to DE. Okay. But now what is in the other triangle? So in triangle CBG, what can we say here? We can say that EC over EB. Why am I going with that? Can you see that's about the same? Is equal to GF over FB. And what's your reason here? Same story. It's the prop theorem with CG being parallel to EF. Can you see that, people? But what do we note now at this point? We can see that CE over EB is the same thing. Not so. So if we have, just take a step back, grade 8, when we told you x is equal to y and y is equal to z, what can we conclude here? Therefore, in conclusion, x is equal to z. Not so. Why? Because y, that is the same. Like if x is equal to 2 and 2 is equal to y, what can we say? Therefore, x is equal to y. Not so? On the same account, on the same understanding, on the same basis, we say the following. If AD over BD is equal to EC over EB, and CE over EB is equal to GF over FB, therefore AD over DB is equal to GF over FB. In conclusion, we can also say therefore AD is to BD as GF is to FB. And they have proven what they wanted. You guys understand? Very importantly, this is a prove that question or a show that question. If that question comes in, here it says prove that, that is the case. I do not use that in the sum. I only come to conclude it. You guys understand? I never use that nowhere in the sum. Okay? So when we mark this question, often the learner, they use that in actually proving what is asked. Okay? So that is question 7. I didn't ask you to do question 8, neither 9, but 10. Correct? Okay? If one of you feel that there's a lesson that you can give to the class, you want to give me a break, like you can do so as well, no? You ready for that, Shirin? To give a lesson? No? Just take a topic and you go learn the topic before I teach it, and then you can teach it. Who's willing to take up the challenge? Nobody? That doesn't be like that. Alright, number 10. We are told in triangle ACE. Again, that's your big triangle. Okay. We are told that BF is parallel to CE. If that is the case, what do we know? We know that AB over BC is equal to AF over FE. And its variations. No? Then, so what I'm going to do is I'm going to take this off and I put parallel lines in. Right, so I know those are parallel and all these variations that come with. Right. Then we are told that BC is equal to 3 over 8 AC. So I say, hang on, that's not what we normally work with. We normally work with the variables over each other, with the lines over each other, not so. So I'm going to divide both sides by AC. So that cancels. So now I got BC over AC is equal to 3 over 8. So what do I do now? I introduce my K. So that's going to be 3K over 8K. So BC is 3K, AC 8K, which make AB what? 5K. If needed, that is 5K. Okay, you guys understand? I take this off here. Make as if I'm smart, no? I can see it's 5K in my head. Right. Then you say and. Also note here, people, as I'm reading the introduction to the sum, I fill in this little points onto the diagram. Yes?
So, how do you know when you introduce a K?
When you were working with your ratios, you introduce a K. Okay, you're going to work with the next ratio as you're going to see. And it's working on a different side of the triangle. Then we introduce an A different variable. And then a B and a C and so on. Okay? You with me?
Yes, sir.
So you got now, this part we're at now. AE over ED is equal to 4 over 3. So, is it on the same side of the line here? No. It's on the other side. So we're going to use a different variable. Okay? So, let's put an A here. So it's going to be 4A over 3A. So AE is 4A and ED is 3A. Okay? The question is, now you see here, there's also a triangle here with parallel lines here. Can you see that, people? So look at that triangle. What can we say here? We can say that if E over ED is equal to BG over GD. Can you see that, people? And all these variations is also evident there. No? Let's take this off. That is all the things you see in your mind's eye, no? In your head. Right. Now we go. You say, okay, you want DG and GB. You see, the nice thing about this work, it doesn't go straight into the answer, man. It doesn't make it boring. No, when you can just read it off the answer, it's boring. No? You want that problem solving skill to come out of you. No? Right. So, people, what is DG over GB also equal to? DG, as I showed you now, DG over GB is also equal to? Sorry? DE over EF. Could I go straight into that? Now, what am I shorting? What am I shorting for that ratio? EF. I'm shorting EF. Okay? So what do I need to do? I need to calculate EF first. Does it make sense? Alright, so let's go. This stuff is just getting sweeter and sweeter. No? Right, so EF. Are you going to calculate EF? You're going to work with EF and? Sorry? EF and? AE. Is that what you're saying? Yes. You all agree with that? Okay, just take it off. So I'm going to say if E. Okay, first in triangle. What triangle am I working in? ACE. In triangle ACE, we say if E over AE is equal to BCS over AC. Why? The proportionality theorem. Let's try and write neater, no? Okay. Whoever said you can do one lesson for us. Who said Sorry? I think it was you. Wasn't. Okay. So you never say stuff like that. Why am I wrong? I'm wrong, okay? The booklet is going to do a lesson for us. Right. Now what? If E is what? Unknown is what we're calculating. Over 4A is equal to BC 3K over 8K. Take it up. The K's cancel. So we say if E is equal to 4A times 3 is 12A divided by 8 is going to be 1,5 or 3 over 2A. Not so. So this is 3 over 2A. Right, now we're going to go into the other triangle. So now we say in triangle. People, something like this is minimum 6 marks. Yes, 12%. So in triangle, what triangle are we going to work now in? DBF or FBD, whatever. What can we say? We go in the ratio they want. Okay, so DG over GB is equal to DG over GB is equal to DE over EF. And what's the reason? The proportionality theorem with BF being parallel to GE. Not so? So DG over GB is equal to, so DE is 3A over EF is 3 over 2A. So of course the A's cancel, not so? So that simply gives us 2, I think it's going to be, or 2 over 1. It's 3 divided by 3 over 2. Yeah, it's 2. 2 over 1. But remember, they want it in what form? What form do they want it in? Ratio form. So in conclusion, therefore, DG is to GB as 2 is to 1. Okay. The nice sum, no? Right. Let's go to the next question. That was number 10. They asked you for 11. Yes, and 12, no? Okay. 11 and 12. Alright, so in triangle, PQR, the big triangle. We are told, yes? I wouldn't let you, I wouldn't penalize you. Because many of them sees the fraction as ratio. Okay? But just to be nice, it is right in the form they give. Okay? So in this big triangle here, we are told that PS is parallel to TB or VT. What can we say from here? That RT over PT equals RB over SB. Not so? Alright, let's take it off. Then we are told that QS over SR is 2 over 3. So what do we introduce here? K. So QS is 2K and SR is 3K. Then they tell us that T is a point on PR. I'll take this off here. T is a point on PR such that PT is to TR as 2 is to 7. So what do I want to put here? An A. Not so. It's A over A. PT is 2A, TR 7A. You will agree with that? So what is the length of PR? 9. You will agree with that? Right. Let's take this one. Now the question says, prove that QU over UT is equal to 3:1. So in other words, it's a proof that will show that question. So that means to say, we must end off with this. Not so? So can we use that in the sum? No. That is why you're not seeing me put a 3b and a b there. Can you see that, people? I must end off with 3:1, or 3/1, or 3 in this case. You guys understand? Right. So what is QU is to UT? Will be the same as QS is to SB. But do I have SB? No. So I must calculate SB first. But how can I calculate SB? In this triangle here. We know that SV over VR, no. SV over SR. Why SR? So I know that is 3K. So SV over SR is equal to what? PT over PR. Can you see that, people? PT over TR. Okay. Take us off here. Okay, so this is the little one I must calculate first. Alright. So it's in triangle PS to R. What can we say? We say that we're calculating SV. So SV over SR is equal to PT over PR. And what's your reason? The prop theorem, proportionality theorem, with PS being parallel to TV. So SV is what? What we want to calculate, not so over SR, which is 3K, is equal to PT 2A over 9A. So what happens now? A is cancelled, take a 3K up, becomes SV is equal to 6 over 9, which is 2 over 3K. You all agree with that? So that is going to be 2 over 3K. Do I have enough information to calculate what they want us to calculate? Yes. So now it's a different triangle we're going to work in now. So we say in triangle, and this is the triangle we're working with. There's your parallel lines. So it's going to be QU over UT, QS over SR. Oops. So we say in triangle QTV. What can we say? We're going to say that what they want, which is QU over UT is equal to, okay, it will be QU over UT is going to be QS over SB. And the reason? The proportionality theorem with US being parallel to TV. So QU over UT is equal to QS, which is 2K over SB, 2 over 3K. Of course the K is cancelled. So therefore, this simplifies into 3 over 1, which is 3. Okay, when the calculator should get that. Therefore, in conclusion, we can say that QU is to UT as 3 is to 1. Alright, you guys understand? Any confusion at this point? No? Let's go to number 12. Okay, we need to make a better cut of this. Alright, 15 minutes left to wrap everything else up. People, number 12, we are told that in triangle QRS, which is a big triangle, we are told that T and U are points on RS, with W in a point on QS. W is a point on QS, such that QT is parallel to UW. Sorry. If that is the case, what can we conclude? We can conclude that SU over UT is equal to SW over SU over UT is equal to SW over WQ. Okay? Then we are told that QR is parallel to WT. If that is the case, what do we know? We know that ST over TR is equal to SW over WQ. You see that parallel lines there? Can you see that? Right. Then we are told, okay, let's just take this off quickly. Then we are told, so that is parallel to that is parallel to this. Then we are told that WQ is 12. WQ is 12 millimeters. WS is 11 millimeters. TU is 6. RS, they want you to calculate correct to 1 decimal place. So in pursuit of calculating RS, what do I need? I need to know the length of SU, and I need to know the length of TR. Not so? Once I've got this length and that length, I've done the job. You just add up all those parts. Not so? So let's go with it. So where do we start? We can calculate SU here. As we know that SW over WQ is equal to SU over UT. You all agree with that? So SU over UT is equal to SW over WQ. The reason? The proportionality theorem with WU being parallel to UT. So SU is what I'm calculating over UT is 6, SW is 11 over 12. You cross multiply, so SU is equal to 11 over 2 or 5.5. You see here I'm not working with K's here. Why? Because all the lengths is given. It's given in terms of lengths. So this is 11 over 2 here or 5.5. Is that correct? Right. Now what? Now we have, I didn't name in which triangle I'm working. So this is in triangle. S U, no? SQ? No. SQT, you are right, absolutely correct. SQT. Okay. Okay. Right, you guys got it? Right. Now, let's work in the other triangle. Always when there's more than one triangle involved here, we tend to name it. Okay. So when you're sitting with it later on, you know exactly which triangle you're working in. People, in triangle, what we're going to work now with? What do I still need? Can I go straight into calculating SR? Yes. So now we're going to work in this triangle. Okay, so we can say SR over ST is equal to SR over ST is equal to what? SQ over WS or SW. Can you see that, people? I'm moving too slow. I can't help it. I need to move slow, yeah? Because I don't want to write the wrong thing down. Okay. So it's in triangle SQ, the big triangle. We're going to say that SR, which is the length they want us to calculate, over ST is equal to the whole length, which is SQ over what? SW. And the reason here is the prop theorem with WT being parallel to QR. So SR, again, is what we're calculating, over ST is 6 plus 5.5. 6 plus 5.5 is what? 11,5. Is equal to SQ, which is 11 plus 12, which is 23, over SW, which is 11. So take it out, up, so it would simply be 223 over 11 times 11.5. That gives us 24. Is that correct? Check the answer there. I think I made a mistake. Check the answer at the back. Is it 24? Okay. Now I'm feeling better. It's going to give you 24,0 something. Or as a fraction. I know they asked you for the decimal. No? So just in case that comes out to be 529 over 22. But this is the answer they want. Okay. Right, that's number 12. Then I asked you to do number 15. Huh? Yes, I did 16 on the board yesterday, in the last lesson. Eh? Okay. I'm going to go straight into 17. Okay? Because we have 7 minutes left. So I'm cutting out number 15. Okay, if you had a problem with number 15 and you watch all these calculations here, you should be able to get 15 right the second time around. Yes, Michael?
So, can I just put writing on top?
Sorry?
Can I just have speaking function on top?
Number 12. Okay. Yes?
So, I'm not sure if I skipped, I don't know, that 11.5, so the ST,
Which with the previous question?
yes, so this one that's ongoing.
Yeah?
The 11.5, so I'm
The 11,5. You remember that this is 5.5. Not so? And this is 6. So we spoke about ST. So that will be 5 plus 5.5 plus 6. It's 11.5. That's where the 11.5 comes from. Okay. Look at the last one. We have not much minutes left. Exercise 1, page 251, number 17. Okay. I'm going to make this a bit smaller. So we are told that in triangle ABC, I think the A belongs to the top, no? Right. We know that P is the midpoint. So if P is the midpoint, what do we know? That this will be K and that will be K. So they're equal in length, so it's 1:1. Not so? P is the midpoint of AC. RS is parallel to AB. RS is parallel to BP, sorry. So what does that mean? That means to say that AR over RB is equal to AS over SP. And all these variations that go with it. Okay? Then we are told that AR is to AB as 3:5. So what do we do there? We introduce an A. So it's AR is 3A. AB, which is its whole length, it's going to be 5A. So what is the length of BR? 2A. If needed, no? And just take this off here. Right. The question says determine AS is to SP. So AS is to SP. But we know that AS over SP is equal to AR over RB. Why? The proportionality theorem with RS being parallel to BP. Not so? So, this we said is going to be 2A. So AS over SP is AR, which is 3A over 2A, which is 3 over 2, not so? So therefore AS is to SP as 3:2. Not so? But there's already a K involved here. Not so? So, in terms of K, we have AS is to SP as 3:2. So this adds up to 5 parts here. Not so? However, this is 3 of the 5 parts, and this is 2 of the 5 parts. Can you see that? 3:2. So that's going to be 3K and 3 over 2K, 3 over 5K, and 2 over 5K. Okay. Otherwise, we could have left the K at this point. We didn't have to put that K in there. Then you would have had 2K is to 3K is to 2K. You could have let this whole length be 5K and 5K if you wanted to. But we put the K already there, so we play it as it is. Okay. Number 2. In question 2, we now want to know what AS over SC. So we go AS over SC, which is this whole length here. Not so. That's simple. So here's no ratio or proportionality theorem applicable here. Not so. Why? Because we know what AS is. What is AS? 3 over 5K. And SC? What is SC in terms of K? K plus 2 over 5. So that's K plus 2 over 5K. You see that, people? Which is 3 over 5K over, that's 7 over 5K, which is 3 over 7. Let's check if that's correct. Right, number 3. Number 3, they want RT over TC. Again, this is the ratio they wanted out here. No? So you just say in conclusion that AS is to SC as 3 is to 7. Okay, you know that's a given. Eh? So RT over TC. RT over TC. But RT over TC is equal to what? RT over TC is equal to what? SP over PC. Not so? Is that correct? It will be SP over PC. I'm not going to say which triangle we're working in. I'm not going to write that down because of the space constraint. Okay, it's that triangle there which is highlighted. And the reason here is the proportionality theorem with PRS being parallel to TP. So RT over TC SP is 2 over 5K over TC PC, sorry, which is K. Is that correct? It's 2 over 5. In conclusion, therefore RT is to TC as 2 is to 5. Are you all okay with that? Right, so we have A, we have K. So that's going to be B. So 2B is to 5B. Okay. Let's look at number 4, and this is why I wanted to do the sum in particular. So you see that I'm keeping all this information on the diagram and the sketch. I want to keep the sketch into focusing, okay, and don't want to move away from it. That's why I erased that.
Your
So
attention,
look at number 4.
Greyhounds, please meet in the prefect. Greyhounds to meet at the prefect. And then all swimmers, the change room is open for you to change into your swimming gear and also to do some warm-ups at the pool now during break. The change room is open for you to get into your swimming gear and also to have your warm-ups now during break. Thank you.
Okay, so at this point, people, here it's speaking about triangle TPC. So it's TPC, that triangle here, over the area of triangle REC. What you notice here is that you don't have a common vertex as we had in the previous one where we can draw a common height. However, what you see that is common in the two triangles.
White House to meet in the hall now during break. White House to meet in the hall now during break. Thank you.
Okay, so what do you notice what is common is? Angle C1. So at this point we have many lengths involved here. Okay? So to calculate the area of a triangle given knowing two sides of an included angle is the sine rule. Not so. So the sine rule for triangle TPC, this triangle here, is simply going to be a half TC times PC times sine of angle C1. Not so. Remember, for the sine rule, I need two lengths and included angle. That's what I need for the sine rule, which I do have. Over RSC, that triangle. So what's going to be say? It's going to be half RC times this length here, which is SC sine of angle C1. Can you see that, people? So the halves cancel, sine C1 cancel sine C1. So TC, what is TC? TC's length is going to be 5B. Whoops. TC is going to be 5B. It's going to be 5B times PC. PC is going to be K over RC. RC is going to be 7B times SC, which is this length here. It's going to be a 2 over 5K plus K. 2 over 5K plus K is going to be 7 over 5K. Not so? So what happens now? K's cancels, B's cancels. Okay, so I'm getting 25 over 49. We check. It's 5 over 7 times 7 over 5. It's 25 over 14. Will you guys understand? Let's check that that's correct before you leave. That's correct? Right. People, all the best for tomorrow's exam. Make us proud and enjoy your event. Good afternoon, class. There's no homework for today, okay? Yes, don't get upset now, no?